So we will see the vector control of this induction motor in this video. We have done programming using microcontroller ARM Cortex M4, which is STM32F407, and we have used National Infotech made high power module, and which has a 4-channel sensor card, and which have 3 IGBT modules, semi-chron IGBT module, and it is standard inverter. And for programming purpose we are using YJoom. You can see over here, this is the code of vector control of induction motor. So basically we are programming the STM32F407 using YJoom. So the initial code is demonstrated in the video. So firstly we will turn on the drive. The drive will initially take 200 RPM reference. So as we will turn on, as we will give the power to drive, it will rotate on 200 RPM. You can see we have given 3-phase supply to our high power module using this variac. So this variac, you can see over here, this variac will give 0 to 415 volt AC to our high power module. We have inbuilt rectifier in the module, and that module will convert some DC voltage. So we are measuring those DC voltage on this meter. We have connected one AC current meter to measure the stator current. This is our AC current meter, and we have connected one analog voltage meter, which is our stator voltage meter. So now we will start the drive. So I'll just give the voltage. So now, as you can see, I have given 640 volt DC link to my drive, and right now I'll test the speed of the motor, as you can see, using this tachometer. So initially around 200 RPM our drive will rotate. Now I will increase the motor speed around 1000 RPM. So I will use this pot to do the thing. So now you can see here, I have given reference speed around 930 RPM, and my measured speed is 930 RPM. It is matching, and you can see my ID, which is my magnetizing current, is staying constant. Right now we can say the motor is on half loaded condition. So ID is around 2 ampere, which is the peak of the sine, and IQ is 1.3 ampere. So as I will increase the load on the motor, my IQ component will increase. So you can see. You can see right now it is around full load condition, and my speed is constant on the full load, and we have a value of ID 1.9 constant throughout the loading and throughout the speeds, and we have a value of IQ 2.5. As I will decrease the load, as you can see on weight scale over here, this is around 9 kg motor, so we can give around 9 kg on 1 meter. So this is its full load condition, and we will do half loading of that. So this will be its half load condition. So you can see the current. So right now current ID is 2 ampere as it was, and IQ is decreased to 1.7. So same thing you can see on the scope. We are showing the modulation index and the angle. This is a rotor flux oriented control. So the angle is shown on the DSO, and modulation is also shown on the DSO. So I'll further increase the speed. So we'll go up to rated, which is 1400 RPM. We have limited the drive up to 1400 RPM. So we'll give 1400 RPM, and we will give the enter command. So as I will press the enter, it will approach towards 1400 RPM. We have given a ramp in the case of increasing reference speed, because we have to avoid the inrush currents. So as you can see, right now motor is rotating on 1400 RPM, and frequency of our modulating signal is increased. As well as you can see, our stator voltage is around 13,309, and the current is 1.4 ampere, which is low load current. We can also verify the speed of the shaft. Right now we have given 1400 RPM. So you can see very stiff performance on the shaft we can absorb. We can load the motor, and after this much loading we can observe the same performance. We are getting 1400 stiff speed on the shaft. And the motor rated current is 2.3 ampere, so we can go up to 2.3 ampere loading. So that is all. And this was the demonstration of field oriented control, rotor flux oriented control of induction motor using STM and National Infotech high power module.